Hey again, YouTube. I just tried to record an intro thing for an Evo video, and it was like 17 minutes. So I'm going to try to speed this up a little bit, and we'll break things down into little sections or something. So anyway, here is my Evo64. I have done a lot of things to it. Some of them probably not necessary, but hey, it is what it is. We'll just start at this end of the board, work our way over, and then maybe I'll record little snippets of things. And I'll try to keep it high level. And if people want deeper dives into things, let me know in comments or on Discord or something, and I could do follow-up videos on specific things I've done to this and why and how, and could it be better? I'm sure it could. So anyway, all right, starting here. I mean, this is an easy one. This is just a toggle switch to ground. I pulled the ground right off of the extra pin on the joystick port there, and it runs over to the Quarry, and all that does is switch NTSC and PAL. That's pretty easy. On the where the optional crowbar can plug in later, the voltage protection kind of circuit. I guess that'll be an option that the Evo guys will sell later. I just blobbed all the 5-volt pins together on the bottom, and that gave me a place to pull 5 volts to do things. So I don't need the jumper caps on here anymore. All the current's actually passing through the solder blob on the underside of the board. So with that, I started adding fans and things because this thing was getting kind of warm. And I added a Pico to it, and the Pico can be driven by 5 volts. So that's pulling right off of there, and that all this power comes from the power supply, the external 5-volt supply, not the internal. Probably is plenty of overhead on this, but I thought, hey, whatever we could keep outside, as far as heat generating, is probably better. So we're going to pull that extra current from outside the machine. Moving over a little bit more, obviously we have the oscillator circuit that's on here, and it is set up for NTSC. The Quarry is set up to use the NTSC oscillator. If I switch the Quarry into PAL mode, it will use the internal Quarry oscillator for PAL, so I don't have to move these jumpers. Speaking about clocks and oscillators, we have this abomination here. This is just a 74 LS14. A couple of 30 picofarad caps going in and out of it, and this is just a 0.1 microfarad smoothing cap, decoupling cap for the power going into the chip. But this is basically generating my PHI2. I've run into issues with PHI2 before. If you look at one of my previous videos on the 5-volt Melius board thing that I did, similar thing was happening here in that PHI2 as generated by the Quarry is just slightly weak, and that's because the PHI0 that actually comes out of the Quarry is a 3.3 volt clock, not a full 5-volt clock, so its duration is just a hair shorter. That pretty much will run everything on here except the SID-FX, but when you start adding a ton of stuff to PHI2, which ultimately comes out of the processor, it actually draws down that circuit just a hair. Things that hook up to it aren't completely passive. There is a bit of load put on the line. You couple that with SRAM being very pissy about PHI2 timing. It has to be dead on. And a lot of the carts, like this is an Ultimate 2 cart, the Kung Fu Flash cart, they're all very, very, we'll call them needy. I don't mean that in a bad way, but all these things are so advanced, they need that clock to be, dead on, balls accurate. And when you start messing with that clock a little bit too much, things start getting a little out of whack. So what I found as a cheap and easy workaround for it is to take PHI0, and I take it out of the test point on the Quarry board that's... pull this out easy enough without bending pins. Shit, yeah. PHI2, hopefully you can see it, is available on this pin header. I'm sorry, PHI0 is available on this test point on the board that I fitted with a pin header. That's just so I could plug things in and out while I was screwing around. But there's a black wire that's soldered onto that, runs around to the input of one of these gates. The output of that gate is just bridged to the second gate. It's just a solder blob on the bottom side. And then the output of that gate is essentially PHI2 at that point. You take PHI0, you invert it once, you have PHI1, you invert it a second time, you have PHI2. So it's basically in phase with PHI0, but just this much delayed. And and that's what times the whole damn system. That falling edge of PHI2, I think, is what is the rug that holds that ties the room together here. So having that as close as possible to perfect is what you need in life. So all that to say, like I said, I can do crap. Did I break anything? No, we're good. I can do another video all on the clock or all on the SID or whatever. Just let me know what you want to see. So at any rate, this is just basically a PHI2 generator buffer kind of circuit, right? Just 2 inverters and that's it. A whole bunch of extra inverters here if I feel like inverting something else. So at any rate, the clock generated from here, I just take and I got it held down to this board here just as a decent place to solder a wire to. But it comes out, goes underneath the board and hooks up. I want to say it was pin E on the cart slot is PHI2. Check the schematics before you go wiring shit in. But that's where I feed it back into the board. Subsequently, I also lifted pin 39 out of the CPU here. This pin 39 is not connected because you don't want this PHI2 and that PHI2 both hooked up. That'll just cause you timing problems and all kinds of weird stuff. So at any rate, that's the clock bodgery I got going on there. This is just a modulator replacement board I used as a handy place to hang an RCA jack and an audio jack so I could plug stuff in to get all these SIDs out. So yeah, on to the SIDs. We have a 6581, 8580, and an ARM2 SID. The ARM2 is running as a single SID with FM Synth, so we have 3 SID support and an FM synthesizer. So you can play those FM demos and whatever else. This was a little weird to get going. Initially, I had the 8580 in this slot and the ARM2 SID up here, and I had a lot of problems with that. And come to find out, and this truly is a feature, not a bug, but it caused me a little bit of grief in that the PHI will send both D420 and D500 to this slot. So if you're listening to a 2-SID tune, you don't have to do anything if they decided to code it for 420 or 500. Problem is, if you listen to a 3-SID tune and it's using both 420 and 500, they're both getting sent to this chip. And a standard 8580 or 6581 cannot deal with that. It sounds like 2 cats got in a fight in an alley in a wet bag. It's not good sounding at all. So the ARM2 SID, being that you have external address lines that you have to take and hook up places, in general, it's just more tolerant of doing weird stuff. So I didn't have any of those problems with both 420 and 500 being presented to this chip at the same time. So when I'm playing a 3-SID tune, I have 400, 420, and 500 running the 3-SID tunes. If we're running a 2-SID tune, the 3rd SID doesn't do anything, or you might actually hear something on it, but I'll just turn down the volume for it in the mixer, and I can have SID 1, SID 2, and FM Synth, or SID 1 and FM Synth, or you can run these two in pseudo stereo, much like the Quarry board implements it, and I could have left channel, right channel, both playing, the single SID tune, and you get that pseudo stereo out of it, and the FM Synth coming out of here. All this is configurable by way of the Pico and the toggle switches that are part of the SID FX. So yeah, I can basically configure it to play whatever, whenever, without doing anything too major. Just flip a couple of switches, whether they're physical or mental switches inside of here. So speaking of the mental switch, this is Insanity's terrible ROM switcher. The Pico is great for this job because A, it's got Wi-Fi built in, it's small enough form factor, it fits in this board real nice. I just double-sided taped it down there. You can feed it with 5 volts, but do not try to put a 5-volt signal into it that actually goes in there. The second pin down on this side, I guess it's really like pin 38, is tolerant of like 3 to 5.5 volts or something like that. So you can basically feed whatever you want within reason into here. You don't need a 3-volt supply for the Pico. Inside here is a diode, because if you have USB plugged into the Pico, this will be hot with the 5-volt there, and you don't want that 5-volt feeding back into the board. So I dropped a diode in this little shrink wrap here, so if I am powering it for programming purposes or debugging or whatever, that 5 volts is not leaking its way back into the board. So what else? Yeah, so the Pico is wired into the REPROM select line, so your K0, 1, and 2, basic 0 and 1, and character 0 and 1. Character 0, 1, and 2. I forget exactly. Well, there's 8 damn pins, right? So the 8 pins on this header on the board, where you would normally have jumpers or dip switches, I just wired into this Pico, as well as the 4 pins for the SID control for your PS and MS lines, your pseudo stereo and main SID lines, as well as DE and DF addressing getting routed to this slot. I'm not actually using any of that because I've wired the ARM2 SID in a wired configuration, but it's there should I ever need it. So yeah, oh yeah, and then the audio routing out the back. I have basically 4 audio lines coming out of this machine. So I have these. I don't know if you can see this guy. This this goes to an RCA jack. This is an RCA jack, obviously, and then I have a stereo jack here. So this is SIDs 1, 2, and 3 in the FM Synth. So that's how I plumb all this stuff out, and I have it going into a mixing board so I can, turn up volume on individual SIDs or whatever it is I want to do. So anyway, that's the overview. I think I'm going to record a couple other sections going into probably the clock, the SIDs, and the Pico config. We'll see what I do with all that. I'm at least going to do the Pico. And if you guys want more detail on what I did with the SIDs and with the clock, let me know and I'll record those sections too. So hopefully this was shorter than 17 minutes for an intro. I'll get this thing rigged up and we'll start playing around with all the switching. All right, we're going to try something new here. I have some background music going. Hopefully it's just subtle and happy. But anyway, I thought I'd take a minute to kind of run through the code that's running on that Arduino or Pico, and so you can kind of get an idea of what I wired in and what the hell it's doing. Now, I have never written anything in C before. I've barely worked on an Arduino, and I've never worked on a Pico before. I'm sure this code can be improved. But anyway, we'll run down it. I haven't figured out how to do file system support or the Wi-Fi manager stuff yet. I want to add that later. So in the meanwhile, you have to hard code your SSID and Wi-Fi password into the code when you compile it. I've seen tutorials on how to do it. It'll probably take me weeks to figure out how to make it work right, where somebody who knows what they're doing can probably do it a lot faster. So anyway, here's all the pins we're using. I have the built-in LED just kind of working as a power LED. Our 3 kernel lines, 2 basic lines, and 3 character gen lines that we use for do the ROM switching for the REPROM. The cart mode pin is that the pin there next to all the jumpers that is for turning this thing into like a built-in cartridge as opposed to a kernel ROM. There again, read the Evo docs. It lays all that out. SID DE and DF is to enable those 2 functions, in that little 4-pin block. The pseudo stereo and main SID, I think, is what it's called in the Evo docs are there. And of course the reset line, because sometimes we got to reset the computer. So all these pins are set to outputs, which means it's either always outputting 3.3 volt or ground. Those pins sit with about 3.5 volt on them on the Evo, so that 0.2 of a volt is getting sunk somewhere, into the Pi. I don't think it's the end of the world. The Pi hasn't blown up yet, but alternatively, you could set these pin modes to change from input to output, and you can do a floating input when the signal's supposed to be high and just let the Evo sit there and float. But it works either way. I don't think it's the end of the world. By default, I pull a couple things low when I start the machine just because I want a specific font and kernel. Otherwise, everything else is high. Remember, high means it's off because you have to pull these things low to make them go, right? So I put little notes in there to that effect. Here's where it connects to the Wi-Fi. So this is basic stuff, came right out of some tutorial on Arduino site or something like that. You know, this just prints out to the serial console when it connected and what the IP is. This web server stuff I grabbed at a randomnerdtutorials.com. That guy's got a lot of really cool stuff up there. Go check out his website. But the web server bit I pulled right out of his code. I might have tweaked one or two itty bitty little things, but that's all the random nerd stuff there. Good dude over there. And then this next section is just GPIO scenarios, right? So the way this thing works is when you call a specific URL, it will call the scenario of pins. So when we're changing ROMs, all we're changing are basically the kernel and basic, right? We want to make sure cart mode stays high because we're not in cart mode, you know, we're in regular kernel mode, right? So this is just toggling all those different lines on and off so we don't have to belabor that point. And same thing for the character generation. We're not touching the kernel, we're only changing the character generator. So there's all the different scenarios for that. And there again, it's just a URL that gets called from the HTML that you click on, right? Moving on down the line, now we get into going into cart mode, right? So we pull that line low because we're going to pull game ROM 0. That's why I called it G0. Could be utility, but it's a cartridge. But I already use C for character, so I call these G for games. Probably a bad coding practice, but whatever. So yeah, we're there again, just swapping all the pins around on that, you know, block of 8 to make all this stuff happen. The character generator pins come into play here because they are used to do ROM selection when you go into cart mode. And here we go, all the different scenarios up to, what do I do, 32 of them, right? 0 to 31. So this will work for like a 29F400 ROM, 512K ROM, right? If you're putting the 1 meg ROMs in there, you're going to have to add 32 more use cases to access the rest of your ROMs. And then there again, we call a URL and it will digital write this pin high or low to change the different SID modes. And there's a little redirect page it goes to confirm it went through and then refresh the page for you. So this is like HTML for 4-year-olds. Here's all the HTML that's actually in all the menus and buttons and things. These are the games I just happen to load on my ROM. You can change this to be whatever games you want. And all this is on GitHub. You can go look through it. But I thought I'd take 5 minutes to kind of run through it. Here's all the submit buttons for changing the SID modes. And that's that. So next up, we'll actually do a screen cap of this thing in action. All right, and this is what the web interface of this thing looks like. It's very no frills. I can't make it better if I wanted to. You know, I can't make it pretty or any of that other stuff, but simple is key here. We just want the thing to work, right? So by default, my machine boots up with those couple of ROMs selected that were pulled low. We're looking through the you know, the pre-compiled stuff, right? So if I want to pick something else, it's just a matter of picking it from a drop down. And if I want to say boot stock, just go in there, hit submit, it flips the switches, sends a reset, and away you go. If you want to go and run a cartridge, just pick the cart, hit submit, and there you go. It's that simple. So granted, you need another device to do it. It's not like you have to wire a whole bunch of switches to the outside of the machine or anything like that, and you have a ton of control, right? So the one thing I noticed that's kind of weird, and it doesn't matter if you're using the ROM switch or dip switches or whatever, certain games do weird stuff to basic memory, right? So Star Wars is one of them, for instance. You'll pick the game, it'll boot up, it'll work, it'll do what it has to do. If you try to go back to a regular kernel, any kernel, right, you'll get a black screen, or it'll half boot, or it'll just do weird stuff. I want to say Star Trek did the same thing, where the game will start, then you try to go back to a kernel, and it'll get hung in a weird state. And if you power cycle the machine, it'll come back just fine. What I found, though, is for some reason Pitfall 2 must reinitialize or clear the basic section of memory. I forget what the hex address offset is for it exactly, but so if you're on a ROM that hangs up the machine or doesn't want to go back into kernel mode or whatever, Pitfall 2 is my bailout maneuver. If I switch to that one first and then switch back to a kernel, it runs fine. So, I don't know. Anyway, moving on, the SID addressing stuff. I had this stuff in drop-downs on an earlier version of this thing, but it was just kind of a pain in the butt. I just wanted to be able to mash a button, right? So if you hit SID1 primary or SID2 primary, that just basically toggles that first switch on that 4-bank of SID control, the MS, I think is what's silkscreen on the board for main SID. SID2 at D400 and D420 is basically the PS jumper. Not basically, it is the PS jumper switch. And that's just pseudo stereo, I think is what the PS means, silkscreened on the board. But this basically just changes what address is getting routed to that second SID socket. Same with these other ones, SID DE and DF. That's just enabling and disabling that extra address going out there. And of course, we can send a reset, and I have this clear page button in here just from when I was screwing around different HTML and whatever else, and it's probably not really necessary anymore. Oh, excuse me, you can probably pull that out of the code and it ain't gonna matter. But anyway, that's the ROM switch, man. It is way too easy to use. All right, let's talk a little bit about how these things are configured and how you can get to the configurations. So, talking about the SIDs now anyway. So if we fire up the SIDFX config tool, our SIDFX is in the first left side, whatever you want to call it, slot. So fire up the program, it just works. And the switch 2 is what configures what addresses they're sitting at. So if you're going to listen to like a regular plain old SID tune and you want it coming out of both SIDs, a lot like the pseudo stereo, they call it on the Evo docs, that's the right position. It sends both SIDs the same data stream. Center mode is D400 and D420 for a 2 SID tune, or if your tune happens to be at D500, it's there. The only downside to all this is that when you change what mode it's operating in, you actually have to power cycle the thing. I'm going to look in to see if there's a way to rig up some kind of reset button just to the SIDFX. Maybe just pull up a diode and a push button to ground or something that you might be able to just reset the SIDFX with. But that'll be a project for another day. In the meanwhile, you just got to reboot the computer when you change modes. But more often than not, I just leave it there. Moving on, if we bail out of here, we'll reset the machine. And if you want to get into the configuration for your ARM to SID, you need to first put the ARM to SID on D400, or the config program can't find it. So flip the magic switch, run the program, and there he fires right up. So if we go into AM address mapping, that's the way this guy's set up. Just a single SID. He makes our third SID. The program thinks it's at D400 right now, and it is, but when you flip the SIDs back with the motherboard switch, then obviously it's going to be at a different address, right? And the SFX is enabled. That's pretty much it. The configuration for the stuff is pretty basic and simple.
I don't want this video to get too long. It tends to aggravate some folks on the internet. But if you want more information on how the SIDs are wired up or whatever, it's pretty much stockish. The only thing I changed really was the on the SID FX I wired it to DF instead of DE. Because I'm going to use DE for other things. So I just didn't want anything there. And for the ARM2 SID, it's there again, just wired for DF only. I didn't use the little pull-up and diode thing to make it switchable. So there again, same reason. I just wanted DE to be available for other stuffs. And that brings me to my one gripe with this board, and that's the addressing. And, you know, the D500 thing where it's always sending D500 to the second SID slot. I wish that was configurable where you could toggle that on or off, much like the DE and DF addresses are set up. And the other thing is that D700, you know, that one hidden address, if you want to call it that, on the 64s, is not easily accessible on here because all the logic is soldered onto the board. Not easily socketable because it's surface mount and whatever else. So in the future, if they could break out D700 somewhere, you know, a newer PLA could probably do it, or even just some mods to the board as it sits now could probably do it. But anyway, that's that. So without belaboring any of that too far, if you want more information on any of this stuff, let me know. I'm happy to take a deeper dive, pull the board out, show you how I wired it, any of that stuff. And with that, I think we should just play a SID tune or two. So my SID FX is in the center position right now. That gives us actual stereo D400 and D420. So here, let's play us a dual SID tune. Alright, and for 3 SID tunes, things are a little less polished, but it mostly works. I'll probably change something, but for now, what I need to do is make SID 2 the ARM to SID primary, and I put it at 400. And that's because the 6581, that is my, you know, primary SID, you know, it's in slot 1 of the SID FX, doesn't really do well with 3 SID tunes. Most of them were written for the 8580. The other thing is I hadn't found a 3 SID player that seems to work and play well with all 3 SID tunes, so I'm using the Ultimate Cart built-in player on there. So anyway, Here's a 3-SID tune. So anyway, that's that. If anybody's got recommendations on a good player I can load off, disk, SD, TIC, or whatever for 3-SID tunes, I'd appreciate that. And things might change. The 6581 thing for the 3-SID tunes is kind of a pain in the butt. So by moving it to one of the alternate tracks, not the primary track, you hear the artifacts and stuff that doesn't sound right less, but it still ain't right. So I might just pull the whole SID FX and put 2 ARM2 SIDs in here, so I can have like one running in 3-SID mode and the other one as a single SID and FM synth. That would give me 4 SIDs inside the machine. Or I don't know, get another 8580, put an ARM2 SID in place, or regular ARM SID in place of the 6581. There's a bunch of stuff I could do there, but I do like having the 6581 in there for the old games. I think it sounds more proper, but yeah, I don't know. Sky's the limit. There's so many choices these days. It's kind of awesome, all the different things we can mix and match. So with that, I will say farewell. I'd appreciate comments, suggestions, anything else could be interesting to do to this machine, or if you want a deeper dive on anything I've done already or whatever, just hit me up. Let me know. Was dual mono, 6581 and 8580. So anyway, that's that. Have fun. Take care. We'll see you next time.